Hey guys, this is Coach Brian with part 2 of your 6.1 through 6.9 test review. Starting on question number 25. For 25 through 28, we need to find a coterminal angle, and it needs to fit into the restricted range here. So it's important to realize that this is just between 0 and 1 full turn, and this is between 0 and 1 full turn. Okay, now it's good practice to look for things that don't fit into this range. So first, we would be looking for negative numbers. Okay, negative numbers don't fit, especially because the baseline is 0. So if it's negative, it's below 0, and we need to get it above 0. We need to make it positive. And so when a number is below 0 or negative, we need to add a positive turn to it. Okay, so in this case, that's 2 pi. When we're talking about radians, a positive full turn is 2 pi, but we need the denominators to match, so we have to rewrite that 2 pi with a matching denominator. So we have negative 5 plus 8, and that gives us 3 pi over 4. That's our coterminal angle. Now, 26, this angle is way too big. All right, it's way too big because for this one, 2 pi, when you have a denominator of 6, it equals 12 pi over 6. 29 is way bigger than that. And you might realize, like, if I give this a negative turn, like I take away 12 pi over 6, it's actually still going to be too big. It's going to be 17 pi over 6, still more than 2. So I have to take that 17 pi over 6, and I have to take away or go in another negative turn. So 17 minus 12 is 5 pi over 6, and that finally fits into my range. For the next one, 410 degrees, that is more than 360. So this is too many degrees. We need to give it a negative turn, which means take away 360. And that drops us down to 50, which fits right in between 0 and 360 nicely. So that one's good. And then lastly, we come back to a negative. Negative is below 0. I need to give it a positive turn to bring it back above 0. Negative 55 going 360 degrees would bring me up to positive 305 degrees. All of these are coterminal because they all terminate on the same line when measured from standard position. All right, for 29 through 37, we're doing the exact value. So you're going to need your special right triangles for this. We need to simplify and rationalize anything, and we're going to do it all without a calculator. So to start with, I like to, for practice, go ahead and just mark all these out. Like this first one, 150 degrees, that's over here in quadrant 2. This next one, pi. Pi is on the negative x-axis. Okay, that's pi. 90 degrees is on the positive y-axis. 90 degrees. And you can do this for all of them. I'll just go a row at a time. So 150, let's zoom in on it. We're looking for the sine. Sine of theta is y over r, also known as opposite over hypotenuse. So what I need to do here is from this point, drop a line straight down and create a 90-degree triangle. Now, since this is at 150, that means this angle is 150. And its reference angle is 30, which makes this a 30, 60, 90. As soon as I know it's a 30, 60, 90, I can label my sides. R is 1. Y is square root of 3 over 2. And X is, I just did that backwards. Y is the short side, so it's 1/2. And X is negative square root of 3 over 2. It's negative because you start at the origin and you go left. Now, sine is y. So all we really need here is this value. So we would say the sine of 150 degrees equals 1/2. Moving to our next, we're at pi. So we're over here at -1, 0. -1, 0. That is my x. That's my y. And the length of this line, the actual length of the line, is my radius, which is always 1. Now, what is cosecant? Cosecant is the reciprocal of sine. So if sine is y over r, that means cosecant is r over y. So I've got my r value, 1. I've got my y value, 0. Anytime I have 1 or any number divided by 0, that is what we would call undefined. Over here at 90, we're up at 0, +1. R, the length of the line, is 1. And cosine of theta is x. So in this case, our x value is 0. Go to the next row. Remember, for all of these, we're looking for x, y, and r. And r is always +1. So now we're looking for 7 pi over 6. So if this is 0 and this is 6 pi over 6, that makes this 3, this 9, and a full circle 12. Now I'm only looking for 7, which is going to be between 6 and 9, but closer to 6. Once we get here, I'll zoom in. We want to go to this point, draw a line to the x-axis, and create that right triangle. Now, the difference or the distance, in this case, it's actually your reference angle, but this angle, okay, is pi over 6, also known as 30 degrees, which makes this a 30, 60, 90. Now, when I'm dealing with a 30, 60, 90, I know my sides, r is always 1. My mid-length side is square root of 3 over 2. And my short side is half, but also think about which quadrant you're in. You're in quadrant 3, where x is negative and y is negative. So both of these have to be negative. And then also, if you remember, all students take calculus. This is my take quadrant, which means tan and cotan are my only positive trig functions. Now here I'm looking for cosecant. That's not tangent or cotangent, so I'm expecting to get a negative answer. And like we said earlier, cosecant is the inverse of sine. So it's r over y. So we find our r, that's 1. We find our y, that's our vertical side, so that's -1/2. And now we need to flip. So we do 1 instead of multiplication, or excuse me, instead of division, we're going to multiply. And then instead of -1 over 2, we're going to flip it and make it -2 over 1. Now, technically, while you're multiplying here, these 1s cancel, and you just have -2 as your solution. So the cosecant of 7 pi over 6 is -2. Let's keep going. Secant of 120. 120 is not quite midway between 180 and 90. It's a little closer to 90, so it's going to be up here in this area. That means this angle is 120 degrees. If we zoom in, our supplementary angle right there, also known as our reference angle, is 60. So that means in this situation, we're working with a 60, 30, 90. 60, 30, 90. Now, we're in quadrant 2. Quadrant 2, where my x is negative, but my y is positive. And just like always, r equals 1. That's our hypotenuse. Y is our mid-size leg of the triangle, so it's going to be square root of 3 over 2. And x is our short leg, and it is going to the left, so it's going to be negative 1/2. Now for secant, secant is the reciprocal of cosine. So if cosine is x over r, we would flip that r over x for secant. R is 1. X is negative 1/2. This is actually the same exact math we just had on this problem. So 1 divided by 1/2, we would keep change flip, and so we'd have 1 times negative 2 over 1. 1's cancel. The answer is negative 2. 34, we're looking for the cotangent of 7 pi over 4. Now, what I want you to see is that this is almost 8 pi over 4. Okay, it's almost 8 pi over 4, which is 2 pi, which is almost a full circle. It's going to be 1/4 turn less than a full circle, or 1/8 of a turn, should I say. It's going to be down here in quadrant 4. When I'm in quadrant 4, that's where all students take calculus. That's my C. So I'm going to have cosine and secant positive down here. So I'm actually expecting, since I have cotangent, I'm expecting a negative answer. So I'm going to connect up here. My reference angle right here is pi over 4. Pi over 4 is 45 degrees. So this is a 45, 45, 90. Now I'm in Q4 where I'm positive in my x, but I'm negative in my y because I'm going down. But since this is a 45, 45, 90, I also know both of my sides are square root of 2 over 2. This one is just going to be negative. R is always 1. So cotangent is the reciprocal of tangent. So if tangent is y over x, that means cotangent is x over y. So my x is always on the x-axis, square root of 2 over 2. My y is always the up and down side. So let me actually make this a little bit smaller. So I got square root of 2. All right, it's just gonna catch that y, even though I don't want it to. There we go. All right, so I've got my x, square root of 2 over 2. My y is negative square root of 2 over 2. And so what I end up with here is a number divided by the negative version of itself. So hopefully you recognize pretty quickly that, oh, any number divided by itself is 1, and then if one of them is negative, it's negative. But if you needed to, you could go ahead and keep change flip. So you would multiply, and you'd flip the second. And if you multiplied this out, you know, you could see these 2's cancel, and so you end up with square root of 2 over negative square root of 2, and they actually cancel 2, and it just leaves you with negative 1. So our solution here is negative 1. Got just a few more left. 35, 36, 37. All right, so tangent of negative 135. Just like we said earlier, when you get a negative, it means two things. You can either go counterclockwise clockwise. All right, you can go you can go clockwise, regular clockwise. My pen is giving me issues and it's distracting me. You can go clockwise, or you can add a positive turn and find a coterminal angle. So whichever one you do, you're going to end up over here in Q3, and you're going to should be perfectly halfway between. So this is negative 135. This is positive 225. All right, they should get you to the same place. Now, when I connect this back up to the x-axis, I'm now just worried about this reference angle. All right, this is 180. This is 225. To get there, I had to go 45 degrees. So that makes this a 45, 45, 90. Both of my sides are going to be square root of 2 over 2. However, I'm in quadrant 3, which means they're both going to be negative. R is always positive 1. Now, I'm specifically looking for tangent. Tangent of theta equals y over x. So my y is negative square root of 2 over 2. My x is negative square root of 2 over 2. Any number divided by itself is 1. So the tangent of negative 135 is 1. Now I'm looking for the cosecant of negative 2 pi over 3. Same thing. You could go clockwise, or you could add a full turn, 2 pi. So see, I have a denominator of 3. That means I would have to add 6 pi over 3. And that equals 4 pi over 3. These two angles are coterminal. They start in standard position. They would finish on the same line. And that line, if I'm over here at 0 and this is 3 pi over 3, that line is going to be down here. 4 pi over 3. Now, when I draw it, you can already see what kind of shape it's taking, but we still want to find this reference. And so to get from 3 pi to 4 pi means I have a reference angle of pi over 3, which is 60 degrees, which means I have a 60, 30, 90 here. So the hypotenuse is always positive 1. The short side is 1/2. In this case, it's negative. The mid side is square root of 3 over 2. In this case, it's negative. And that's my x. This is my y. I'm looking for cosecant. Cosecant of theta equals r over y, because sine of theta equals y over r, and you have to flip it to find the reciprocal. So in this case, the cosecant of negative 2 pi over 3 is going to be 1 divided by negative square root of 3 over 2. Now, I'm dividing by a fraction, which means I need to keep change and flip. So I'm going to keep the 1, multiply by negative 2 over square root of 3, and that gives me negative 2 over square root of 3. Now, I still can't leave it that way, so I need to rationalize. That will give me negative 2 root 3. Square root squared leaves me with just the 3. Last one for this section, negative 3 pi over 2. You could go in a negative direction. If this is 0, this is pi, this is pi over 2. That would make this negative 3 pi over 2. Or you could add a full turn to it, and that would bring you to positive pi over 2. No matter what, you're up here on the positive y-axis. And when you're up here, you're at the point 0, 1. So that's an x and that's a y. And the length of this line, r, is always 1. Let me clean that up. Now, I'm looking for sine. Sine of theta is y. Right here, my y is 1. Where did I get that? Right there. That's my solution. All right, one left. Find the exact value of the other 5 trig functions of theta if theta terminates in the given quadrant and has the given function value. I'm going to start just by showing you this one. I'm not going to do it for you. I am going to run out of time, so I'm going to do 38b. But for these, it tells me it ends in quadrant 2. That is a negative, positive quadrant. It's also my all students take calculus. So sine and cosecant should be positive, which means right here I'm looking at a negative answer. Also, secant is r over x. And if r is always positive, okay, if you remember that from your notes, always positive, then that means the 4 is what's negative. This is positive, this is negative. So that means my x value is negative 4. I'm going to go over here. That's negative 4. And my hypotenuse is 5. So I have this missing side of my right triangle. And you could use the Pythagorean theorem to find it, or you could recognize that this is a 3, 4, 5 Pythagorean triplet. And so what you would do now is you would just make your list of all of the trig identities, the trig functions, and obviously you already know the secant because it's given to you, but you would want to find all the remaining 5 using the numbers from this triangle. So I'm going to do this last one with you, just because it's a little more difficult. It's Q3. That's a negative quadrant. That means my x value and my y are negative. It's also my all students take calculus. So that means tangent and cotangent are positive down here. See how this is tangent and it's positive? That's because I'm in Q3. All others that aren't tangent or cotangent should be negative. Now, if you're looking at tangent, tangent is y over x. So that means my y value is 1 and my x value is 3. But if I go over 3 and down 1, that doesn't put me into Q3. That puts me in Q4. Okay, I shouldn't be there. The reason for this is because, actually, sorry, it wouldn't even put me in Q4. It would put me over, if they were both positive, it'd put me in Q1. All right, it'd put me in Q1. And I'm not supposed to be in Q1. I'm supposed to be over here. So how do I get over there? Well, it's because both of these values are actually negative. So the 3 and the 1 are negative. And if you did a negative over a negative, you get a positive. That's why a tangent is positive. Now, we do have a missing side here that we don't know. So we need to use the Pythagorean theorem. So we would do negative 1 squared plus negative 3 squared equals c. I'm going to go ahead and square root the left side so that I don't have to do c squared. So what we're looking at here is the square root of 1 plus 9, which is the square root of 10. And that can't be simplified. So we know that our unknown side here is the square root of 10. And we're always dealing with this angle right here. And we would go through this list using our sides to figure everything out. So sine is y over r. That'd give me negative 1 over the square root of 10. I need to rationalize that. And so it'd be the negative square root of 10 over 10. Cosine is x over r. So that'd be negative 3 over square root of 10. I need to rationalize it. So that would be negative 3 root 10 over 10. Tangent, they already gave me. It's 1 over 3. Now, for these others, cosecant, secant, and cotangent, these are all reciprocals. So I'm going to actually take what I have above and just flip it. So that would make the cosecant root 10 over negative 1, which is just negative root 10. For a secant, it would be root 10. Sorry, I can't write. It'd be root 10 over negative 3. And for cotangent, it would be negative 3 over negative 1, which is just 3. So there are your 6 trig functions, and that is part 2 of your review. I hope it helps you prepare for your test. Do your practices, do your classworks, and good luck.